Hi everyone, today I am here to explain the definition of FEM and the basic steps involved in FEM. Let's see the definition. FEM stands for Finite Element Method. It is a numerical technique used to solve complex engineering problems by dividing them into smaller, simpler parts called finite elements, and FEM has become a widely accepted method for the solution of a wide range of engineering problems. And basic steps involved in the FEA are problem definition, mesh generation, and element type and material assignment, and boundary conditions, equation formulation, assembly and solution, post-processing, and validation and iteration. Let's see one by one. Very first one is problem definition. Clearly define the problem you want to solve and establish the objectives and constraint. Identify the geometry, material property, and boundary condition. And the second one is mesh generation. In this, create a mesh by dividing the geometry into a finite element mesh. This involves discretizing the domain into smaller elements such as triangles, quadrilaterals for 2D problem, or tetrahedral or hexahedral for 3D problems. And third one is element type and material assignment. In this, select appropriate element type based on the problem and assign material property to each element. And different elements have a different behaviors and mathematical representation. And boundary condition. Fourth step is boundary condition. In this, define the constant and load applied to the structure. This includes specifying fixed displacement, forces, pressure, temperatures, or any other relevant boundary conditions. And fifth one is equation formulation. Formulate the governing equations that describe the behavior of the structure. This typically involves using the principles of a solid machines such as equilibrium equations and constitute equation. And sixth step is assembly and solution. Assembly the equations for individual elements into a global system of equation. The system is then solved using numerical technique to determine the unknown nodal solutions, displacement, or other desired quantities. And the seventh step is post-processing. Here, analyze and interpret the result obtained from the solution. This may involve extracting quantities of interest such as stresses, strain, displacements, or any other relevant output variables. And visualization techniques are often employed to better understand the behavior of this structure. And the eighth step in FEA, finite analysis, is validation and iteration. Validate the result by comparing them with analytic solution, experimental data, or known benchmarks. If necessary, iterate through the steps to refine the analysis until satisfactory results are achieved. This about the steps involved in FEA, finite element analysis. Conclusion: FEM is a powerful tool for solving complex engineering problems. By dividing the problem domain into a smaller, simpler parts, it allows engineers to simulate and analyze complex systems that would otherwise be too difficult or expensive to analyze using traditional analytical method. FEM has become an integral part of many industries including aerospace, automotive, and civil engineering among others. Thank you.